means weight has been countered by the air resistance, object falling at terminal velocity, and then parachute opens. Once again, the speed decreases drastically, and after some time, where terminal velocity comes again, and the paratrooper touches the ground. Okay. So cyclist takes a ride lasting 25 seconds of journey is there. The diagram shows her distance traveled from starting position varies with time. What is the average speed of the whole ride? So that graph shows 25 seconds journey and total distance covered is 150 meters. So total distance covered upon total time will give you, I guess, 6 meters per second of speed. Okay, lorry take 15 minutes to travel along a path, PQRS. What is the average speed? Again, total distance covered upon total time. So total distance covered here is 8 plus 3 plus 5, that is 16 kilometers upon 15 minutes. So that needs to be converted to hours. So 15 minutes will be, you can do it in 2 ways. 16 kilometers in 15 minutes. So in 1 hour, it will be 4 times, means 64 kilometers per hour. Or you can convert minutes to, if you are finding it difficult, you can convert minute to hours, so that will be 0.25 hours. So 16 upon 0.25 will give you again 64 kilometers per hour. An object travels at constant speed of 10 meters per second for 10 seconds. During the next 5 seconds, it accelerates uniformly to 20 meters per second. What is the total distance traveled? So area under the graph will give us the total distance covered. So we can see here, we can divide it into a big rectangle and then a smaller triangle. So in that case, it will be 10 into 15, 150, and then half into 5 into 10. So that will be 25 plus 150, so that will be 175 meters. Or you can also make it a trapezium and then a smaller rectangle. The graph shows how speed of the car traveling in a straight line changes with time. Which section shows the largest acceleration? So steepest part will be giving us the largest acceleration, that is part A. B acceleration is less than that, and C is almost horizontal, that means zero acceleration, and D is deceleration actually. So the steepest one is A, largest acceleration. Okay, speed time graph represents a journey. Which distance time graph represents the same journey? So speed time graph, that gives an constant acceleration, increasing speed. So increasing speed means it cannot be option C, it cannot be option D, and it cannot be option B because that's giving us the decreasing speed. But we have an increasing speed, so option A, that is giving us increasing speed means acceleration. The diagram shows speed time graph of motion of a car for 4 seconds. What is the distance traveled by the car in 4 seconds? So area under the graph, that can be divided into a rectangle and then a triangle. So that will be 10 into 1 and then half into 3 into 10. So 15 plus 10, that will be 25 meters. Option B. A cyclist travels along a hilly road without using a package or brakes. Air resistance and friction are negligible. The speed time graph of the cyclist is shown. At which point did he reach the bottom of the first hill? So at the bottom of the first hill, speed will be higher. So what happens for the first time is at B, you can see from A to B speed is increasing a lot, so that will be the bottom of the first hill. At B, you will be at the bottom of the hill with maximum speed. A car travels along a road at 50 kilometers per hour. The driver applies brakes and okay. So that's where we start dynamics. So we'll be discussing, no, that's not dynamics. So we'll be discussing this MCQ later. When a heavy rain falls a short distance towards the ground, it doesn't reach terminal velocity because it takes time. Why is this? The coin has not hit the ground. Sorry, so the coin has not hit the ground. Weight of the coin equals the air resistance. So if it equals, then terminal velocity is achieved. So he is saying that terminal velocity not achieved. Weight of the coin increases at air resistance, so that doesn't happen. Weight of the coin is always more than the air resistance in that journey, so option D. Air resistance still has not balanced the weight. Speed time graph of falling skydiver is shown below. As he falls, the skydiver speed spreads out his arms and legs and then opens his parachute. Which part of the graph shows the skydiver followed with terminal velocity. So now there is a technical point here that skydiver has opened the parachute. So we discussed the freely falling objects graph earlier also. So for a skydiver, we had seen that terminal velocity was achieved twice, but here he says that parachute has been opened. So we are talking about the second time, that is option D. Okay, table tennis ball is released from the top of an evacuated tube, which graph shows how the speed of the ball changes with time as it falls to the bottom of the tube. So there is no air resistance. So speed is increasing, acceleration is constant, and we cannot go for option C and D, which are showing that speed is decreasing. We can go for A and B, and A is showing constant acceleration. B would have been if there would have been air resistance, but now we'll be going for option A because in absence of air resistance, acceleration will be constant and speed will be increasing at constant rate. The graph shows how the height of an object above the ground changes with time. What is the terminal velocity? So you can see here at first horizontal line, it means it was starting to accelerate. And then the part where we have a constant inclined straight line. So that shows constant deceleration. Sorry, uh, that doesn't show constant deceleration. That shows speed is constant. Okay. So that shows terminal velocity. Terminal velocity is where speed is constant and acceleration is zero. So straight inclined line will be showing. Achha, now you'll be confused about negative gradient of this graph. Basically, it is height above the ground and time. So height above the ground is decreasing, object falling down. So that inclined straight line is giving us the terminal velocity. So we can find out the answer. So what is the terminal velocity? So we can have a reading here from 1 to 2 or 1 to 2.5. That's exactly a straight line. If you find it difficult, you can place a scale here and identify the straight part of the slope. So 1 to 2.5, that will be okay. Why not take it from 1.5 to 2.5? That's 1 second. It will be easier for us. So speed height decreases from 2 to 0. 2 upon 1, that will be 2 meters per second. So the diagram shows a parachutist in 4 positions after she jumps from the height. At what position does she have terminal velocity? So A, it's not moving. B, accelerating, it will not be terminal velocity. C, it's not accelerating. So option C will be the right option. The graph illustrates the motion of an object. Which feature of the graph represents the distance traveled by the object while moving at a constant speed? So that is area under the graph of D. Okay, so that's all for kinematics.